I am an ER doctor, work full-time in an emergency department, love what I do, but I also love talking about the wonders of human biology, which is why I'm here today. And today I want to talk to you about what I consider to be one of the most beautiful, amazing architectural pieces of biological architecture imaginable, and that's the DNA molecule. Now, I'm going to go to my computer for a second. You may hear me say to my computer, back to me. That's because Daniel, a really wonderful guy here out in California, is helping me, and he's going to make the exchange for you to see me on a camera and then right to my computer screen. So Daniel, to my computer screen for a minute. Now, most presentations would start something like this. We're not going to do a presentation like this, but let me just share with you how most presentations about DNA would start. And they would start with me showing you four cells rather. I hope you can see the pointer here. Here's one cell, here's another cell, here's another cell, and here's another cell. There's four cells here. They're under an electron microscope. Now, those cells are small. 1,000 of these cells would fit at the end of a period. Okay, so we're talking about a pretty darn small space. The DNA that we're talking about lives in the nucleus. That's the center part here, the hub of the activity of the cell here, and here, and here. And the DNA actually doesn't live in just any old part of the nucleus. It actually lives in even a smaller part of the nucleus as well. So again, what I'm talking to you about is very, very tiny spaces, nano level, micrometers in dimension, really, really tiny, tiny spaces. Now, you can't see the DNA inside the nucleus right now because it's very thread-like. It's invisible. You can hardly see it. But at some point in the life cycle of this cell, the DNA clumps and aggregates and starts to look like this. These images that you're seeing are really true images of DNA clumped together. And they're called chromosomes. Clumps of DNA are called chromosomes. So what I want to do this morning with you is I want you not just to learn the science of DNA, because you really can go to an internet site or go to your textbooks or your iPads or whatever you're using, and you can see millions of places to learn about that science. I'm hoping to show you in a different way how DNA moves, how productive it is. I want to give you a visual signal, a visual cue, a visual metaphor, so you can appreciate the dynamic movement and productivity that goes on in the cell. I want to show you how it works, not just about it. And it's a beautiful activity as well. When I look at DNA, I see a dance musical because I see molecules moving about from one place to another rapidly in a coordinated manner that honestly, it spoke to me about a dance musical. And as a result of that, I worked with an animator, and I worked with students at the University of California at Berkeley, dance students in the dance department, and we created a movie. And the movie's about a 12-minute movie, and that movie talks about DNA, the dance of life, and it gives you a feeling of the beauty and the dance that's going on inside DNA. It won't give you all the science. I do try to pepper it with some of the science, but I want you first and foremost to see the flow, the motion, and truly the musical that goes on inside the DNA molecule. Now, I am going to give you time to ask me some questions at the end, and there's no such thing as a foolish question. Every question that comes out of your mind is important and a good question, I'm sure. You're going to have time to stump me if you want, but please be easy on me because I'm not a molecular biologist. I'm not an expert in DNA. I am just someone who loves studying human biology, and I truly feel that DNA is just at the top of that list. So here we go. Let's watch this movie. coming right up. I don't know the volume.
As we travel into the human body, we are immediately confronted by its complexity. The body is home to an estimated 100 trillion cells. The amount of activity going on in just one cell is beyond anything we could possibly imagine. It's producing proteins at an incredibly high rate. Simple sugars are needed to fuel this production, while amino acids are the building blocks needed to make these proteins. If the cell is like a planet, then the nucleus is like an energetic city needing simple sugars and amino acids to power this production. The portion of the nucleus responsible for this production is called the chromosome, a place that can be thought of as a dance studio. And it is within this studio that we find the DNA molecule. It is within this DNA that we meet our principal dancers, or base pairs. Their scientific names are adenine and thymine, and although classified as nucleoproteins, in this metaphor we can think of them both as dancers. And wow, can they dance! These two nucleoproteins are cytosine and guanine, and like adenine and thymine, they are incredible dancers too. Directing these dancers is Mr. RNA polymerase, the choreographer, who represents an enzyme in charge of protein production. The phone call represents the body communicating its need for a new protein. As Mr. Polymerase selects the dance instructors needed in this production, they release their hold on their former partners and turn around to face him. Mr. Polymerase explains to the dancers that there is a production tonight at the Theater of the Ribo. The ribosome, a place far away from the nucleus where protein production in the cell ultimately takes place. There are new steps to be learned for this production, and it will be their job to teach a group of new dancers these steps. Mr. Polymerase shows the dance instructors the steps for the new dance. Mr. Polymerase calls additional dancers that live in the city, the nucleus, to come to the studio. They are identical nucleoproteins, clones if you will, of adenine, thymine, guanine, and cytosine. The new dancers board the M train, which will take them to the dance studio. Among these dancers is the fifth and final nucleoprotein that resides within the nucleus, called uracil. Like her colleagues, adenine, thymine, guanine, and cytosine, she is also very particular about her dance partner. The M train arrives at the dance studio, where the dance instructors have been anxiously awaiting the arrival of the new dancers. As the new arrivals meet their dance instructors, uracil chooses the instructor adenine as her dance partner. The new arrival adenine chooses thymine as his dance partner. Cytosine arrives and partners with instructor guanine. And finally, guanine partners with instructor cytosine. The dance instructors begin teaching the new dancers the steps for the new production. The new dancers, having learned the dance, once again board the M train and travel to the dazzling Theater of the Ribo. Backstage at the Theater of the Ribo, Mr. Polymerase tells the newly arrived dancers that still another group of dancers will be arriving momentarily on the T train. These new dancers will not only perform with them, but will also be performing their own dance. This will be the finale of the show. The new dancers arrive holding the props needed for their performance of the finale. Now that both groups of dancers have paired up with their partners, they begin rehearsing the dance. The new arrivals have learned the dance steps and are ready for the dance performance. It's showtime! The first act is a great success. Mr. Polymerase introduces the finale. As you can see, each group of 3 dancers release a ball representing an amino acid, an essential building block for protein production. Thousands of amino acids are released at the conclusion of this production, forming chains called proteins. This process of protein production takes place continuously on the more than 3,000 ribosomes contained in a single cell, making just one cell capable of producing 8 million proteins in a single day. Once made, these proteins are distributed throughout the 10,000 miles of blood vessels to organs within the body for specific uses. And responsible for all this productivity is DNA. Let's recap in scientific terms what we have learned about DNA and protein production. Under the constant direction of RNA polymerase, certain DNA nucleoprotein partners, adenine and thymine, guanine and cytosine, are commissioned to separate from one another. New nucleoprotein partners are directed to replace the former ones, creating a new nucleoprotein line called messenger RNA. The nucleoproteins of messenger RNA link together in a very exact order and then leave the nucleus to travel as a group, like a chorus line, to a place some distance away called the ribosome. This is where the final production of protein takes place. Another group of nucleoproteins called transfer RNA has also been directed to the ribosome to pair up with messenger RNA. The pairing of these 2 lines of nucleoproteins is executed with amazing precision, something we will talk further about later in this presentation. Transfer RNA has the added task of transporting amino acids. When linked together, these amino acids form proteins, a fundamental building block of life. In the curriculum that follows, you will gain more detailed insight into one of the most intricate, remarkable, and amazing pieces of biological architecture imaginable. We will talk about the language and alphabet of DNA, its use in drug development and new products, its potential for gene therapy, as well as many more applications that will have a major impact in your lifetime.